All right, guys. The next lesson in this unit is on something called mutually exclusive events. All right. So it might sound a little bit fancy, but it's actually not that bad. Actually, the main thing out of this section or this lesson is something called Venn diagrams. Now, you may have seen these before, it's basically Venn diagrams. They kind of look like these things here. We have kind of rings and yeah, and these numbers here. So I'm going to go. I think it's the best to describe or teach Venn diagrams through an example. All right, so let's just kind of jump into this first one here. Okay, so for example one, this thing is kind of important where it says for the Venn diagram, each dot represents an equally likely outcome. Okay, so all that means is that each one of these dots represent the same amount of probability. Okay. Okay, so anyways, let's just jump straight into it. So this first one here, we're going to find the following probabilities for this example. The first one we're asked to find here is the probability of A. Okay, so probability of event A. All right, so to answer this, remember probability is, actually I'll write that up here. So probability of A or any event A is equal to favorable outcomes divided by total outcomes. Okay, so that's your basic probability formula. Okay, so if we look here, you can see that within ring A, which is this green ring here, we got 4 here, but we also have this 1. Okay, that's overlapping with event B. Okay, so in terms of the number of favorable outcomes for event A, it's actually going to be 5. Okay, so we got the 4 plus the 1. Okay, so this would be 5. And then the total number of outcomes would be each one of these dots here. So if I count these up here, let's see here, 5, 6, 7, 8, 9, 10, 11. Okay, so there's 11 total possible outcomes or 11 dots. All right, so the probability of event A would be 5 over 11. Okay, so 5 out of 11. Okay, so again, yeah, total outcomes for this, actually I'm gonna write that up here. The total of dots, total number of dots is 11. Okay, so we're gonna be using that basically in the denominator at the bottom of the fraction for each one of these. All right, so let's go to probability of event B. Probability of event B, you can see that there are 2 by itself, but we also have this 1, right? So there's 3 dots within the ring of, within the blue ring, okay, which represents event B. So the probability here would be 3 out of, and again, the total number of dots there would be 11. Okay, so that would be, that's the probability there. All right, next up, so I'm gonna scroll this down a little. Probability of A and B. Okay, so now what I'm going to do here is actually show you some notation, all right, because it's actually going to be written in notation. So this is the same as when you see this probability of A, and it's read intersect B. Okay, so when you have this kind of like upside down U thing, this is basically we're looking at where A and B happen, which is where the overlap. Okay, so how many times does A overlap with B? All right, so you'll see here in the diagram, there's only 1 dot that's overlapping between A and B. So therefore this probability would be 1 out of, and the total number of dots is 11. All right, so that's, yeah, so that's A intersect B. All right, actually maybe I'll write that in quotation. So A intersect B. Okay, so that's how that's read. Okay, so probability of A and B, whenever it says and, it's both are happening at the same time. Okay, so that's only 1 dot out of the 11. All right. Next up, probability of A or B. Now I'm going to show you the notation for this as well. This is the way you'll see it. Is probability of A, and then this time instead of being like a upside down U, it's an actual U. All right, so if you see it this way, this is A or B. Okay, so these mean the same thing. This is just a notation. Okay, so this is actually read A union B. Okay, so if you hear me say A union B, It's basically where A or B happens. Okay, so the difference between and or is like either one of them happen or the other happens or both happens. All right, so A or B would be, in this case, if we count the number of dots, we have 4 here, plus the 1 plus the 2 and only B. Okay, so therefore the probability here would be, try to count that up, 7. Yeah, 7 dots there over 11. Okay, so yeah, so we need to know the difference between A and B versus A or B. Okay, so A and B means that they're happening at the same time. So in this case, that's just 1 dot. A or B is the one or the other, or is this or both. Okay, so that A or B would be a bigger probability every time. Okay. All right. So so yeah, that's important to note the difference between and or. Okay. I just noticed that I wrote this instead of quotations here. All right. So A union B. That's what it's written. Okay. Now the next up here. This is more notation. All right, so this is A with, or probability of A with a line on top of this. All right, this is actually the same as probability of not A happening. Okay, so in other words, there's a couple ways we could figure this out. The first way is basically just to count, right? So this is the probability of A, these 5 dots. So not A would be the ones outside this ring. Okay, so there are 1, 2, 3, 4, 5, 6. Right, so the 2 here plus the 4 here. Okay, so this would be 6 out of 11. So probability of A not happening is 6 out of 11. Okay. The other way to realize that you can figure out this probability, so I'll just write or here, is this is going to be the same as 1 minus probability of A happening. Okay, so the 1 here is like 100%. So if I take 100% minus the times that the probability that A does happen, if I subtract that, that should give you the probability of not A happening. Okay, so that would be the same as 11 over 11 minus, and then up here, probability of A happening is 5 out of 11. So if I subtract those fractions, I get 6 out of 11, right? Which is the same as when we just counted them all. Right? So, so this is a probability of A not happening. Now this does actually have a name, just like these other two here. This would be the complement of A. Okay, so yeah, so the opposite of A happening is the complement of A. Okay, so probability of it not A. Okay, so likewise, this one here is the probability of not B happening. And so here I'm going to just, rather than scrolling up and counting here, I'm just going to use this one here. Okay, so if it's 3 out of 11, that B does happen. That means that 8 out of 11 times B is not going to happen. Okay, because yes, so the event B happening plus the event B not happening should add up to 100%. All right, so hopefully that makes sense. I think with this here, it's mostly the kind of like the notation that's being introduced here. Okay, so you will see on your worksheet and on the assignment things written this way. Okay, so it's important to know the difference between those two. Cool. All right, so let's go on to the next one here. So we're going to use another Venn diagram. Okay, so a communications company surveys 90 households. It found that 75 homes have at least one smartphone, 58 homes have at least one tablet, 50 homes have both a smartphone and a tablet. We want to know what is the probability that a randomly selected household will have a smartphone or a tablet. All right, so there's a lot of words going on here. So whenever we come across these types of questions, what we're going to do is we're going to set up a Venn diagram. Okay, so this is my boxes. The box itself should add up to the total. Okay, and then what I'm going to have is I'm going to have 2 rings, and I'm just going to label these here. So let's call this one here S for smartphone, And this other ring would represent the tablets. Okay, now, when we're trying to figure out the numbers in here, it says there's a total of 90 households surveyed. Okay, so all the numbers that add up should add to 90. We found that 75 have at least a smartphone. So 75 would be this entire ring. Okay, so if I added these two numbers that I have, that I'll come up with here, it should add up to 75. All right, likewise, 58 phones will have at least one tablet. So these two here, these two sections here should add up to 58. And 50 have both. All right, so the key to these questions is to actually start here, where it says both. Okay, because we automatically know, if I know 50 homes have both, that means the overlap is 50. So right away I can put the number 50 in there. Okay, because this region here represents the number of households that have both smartphones and a tablet. All right, now at this point, what we can do is we can kind of work our way backwards. So if I know 75 homes have at least one smartphone, that means this whole ring here has to add to 75. So if I have 50 there, that means that 25 households will only have a phone and no tablet. Okay, so again, these two rings must add to this total here. All right. And likewise, if 58 homes have at least one tablet and 50 have both, that means that 8 will only have a single tablet, or only have tablet and no phone. All right, now to complete this, if I add these three together, these three numbers together, so if I take 25, add it to 50 plus 8, this adds to 83. Okay, but there were a total of 90 households. Okay, so from that we can figure out how many households actually don't have either. So if 90 were surveyed, but 83, these three numbers add to 83, that means that I'll have 7 left over, 7 households left over that don't have neither. Okay, so this is your Venn diagram. And from here, we can actually answer this question. All right, so what is the probability that a randomly selected household will have a smartphone or a tablet? Okay, so the key word here is or. Okay, so again, if we scroll back to remember in the previous example, when it came to or, it was one or the other or both. Okay, so here the or would be, and actually I already added up here. Okay, so the or part, let me just highlight it, would be these three numbers added together. Or in other words, let's do a little coloring here. This is the or. Okay, so those three numbers add to 83. So therefore the probability, the answer is going to be, so let's write that out actually, probability of a smartphone or tablet is that total there was 83 and the total was 90. So that would be my probability of a smartphone or a tablet. Okay. If I wanted to find the probability, now I'm just going to kind of add this in here, but let's say, let's kind of like bonus, but let's say probability of only having a tablet. What would that be? Okay, so in this Venn diagram, you can see that 8 represents the total number of households with only a tablet. So the probability would be 8 out of 90. Okay, and so on. So once you get this Venn diagram set up, we can answer a whole bunch of these different questions. Okay. Cool. All right. So let's see here. Yeah. So let's go on to the next one here. Okay. So the last little thing that I actually have to cover is what does it mean by having a mutually exclusive event. All right. So so two events are mutually exclusive if they cannot happen at the same time. Okay, so in other words, if the probability of A and B is equal to 0. Okay, so in terms of a Venn diagram, it is when we have these two rings, but they actually don't overlap. Okay, so there's nothing that overlaps in them. Okay, so for example, these are kind of examples. that are mutually exclusive. So let's say off a deck of cards, if you're drawing a red card and a black card, those are mutually exclusive. Right. The reason for that is when you draw a card, it cannot be both a red and a black card. It's going to be one or the other. Okay. Another example is rolling an even number and an odd number. Okay, off I guess I didn't really complete here, but with a dice, right? So, or with a die, all right? So, for that one here, actually, maybe I'll draw the Venn diagram. See, that's even and odd, right? You can have, for even numbers, you can have 2, 4, and 6. And for odd numbers, it could be 1, 3, and 5, right? But what you'll notice is there's no number that you can roll that would overlap both of these. All right, so therefore they are mutually exclusive. All right, so again, if two things cannot happen at the same time, those are mutually exclusive events. All right, cool. All right, so let me just show the worksheet, the practice worksheet for today. So yeah, so basically, this again, these two, numbers 1 and 2. These are just using that notation of that first example, reading it off a Venn diagram. And then, yeah, 3 and 4 is similar to the I guess the word problem that I went over in the lesson, right? So those are just, yeah, so practice 1 through 4. And again, the answers are right there. Cool. All right, guys, have a good one. Bye.